Hello everyone, welcome back. This is part 2 of Fractal Trees. Whenever we left off, we were getting started on branch. We're working with JavaFx. Let's kind of show off what we got so far. It's not a lot. I know, it's all just getting started. But we have this beautiful little bit of code. We have these variables that are setting our width and height. We end up using them down here. And what this does is kind of basically set the size of our window, right? Oh, that's chat. The size of our window, this is 400 pixels by 400 pixels. We set the title here to Fractal Trees, and that kind of resonates up here. And so this is all measured in pixels. One of the key things that I kind of talked about yesterday is that the origin is actually up here in the upper left-hand corner, right? The 0, 0 is here. So X goes positive going this way, and Y goes positive going this way. And that's super important. We're making a new branch, right? We're getting started with it. And the first thing we do is kind of create an origin point, which is just an X and a Y wrapped into one object. And notice that it varies based on the width and the height. I did that on purpose, right? If we decide to come up here and make our window bigger, our tree trunk, right, for our fractal tree is going to adjust accordingly. So in order to make a line, right, a line is part of JavaFx. What we need is an X and Y starting location and an X and Y ending location. Okay, but in order to actually make a line, I need basically a starting point, right? This is our X and Y point 2D object. We're just taking the X and Y and throwing it in. I'm going to have a rotation, right? So what we're going to end up doing is drawing the line based on this point and based on a length. So I'm going to have to do some calculation to figure out where does the line start, how long do I want it to be, okay, I need to figure out where does it end, and that varies based on the actual rotation. This is actually pretty tricky. I didn't learn this math. I'm Southern educated, and we just skimmed right over, stuff I may need later in life. So what I'm going to do now is plug in a bit of a helper method. And like I said, I had to dig to basically find this. We didn't learn this. We didn't learn this in school. If you are very math inclined, geometry is your thing, I kind of recommend like pausing this and seeing if you can figure it out. Can you, given these things, right, a point of origin, a rotation, and a length, figure out the endpoint? That's ultimately what we're going to do. I have this helper method coming in. It's going to spit back out my endpoint that I need, right? So it is going to return a point 2D, and I'm calling it endpoint. Given this information, an origin, a rotation, and a length, right? The same information that's coming into my branch, I'm going to pass it on to this endpoint method to figure all that out. Now, I could just do it all here. No, actually, I do end up calling this twice. So this method is a good one to have. First thing I'm going to do is pull out the X and Y from my origin, or origin. So I'm going to create this double. It's a little odd to be using doubles here to some people, right? Because ultimately this is dealing with pixels. And in my mind, like a pixel is kind of an integer, but they're doubles. I think we can have essentially a fraction of a pixel. Maybe that's not right. So I'll take my origin. I'm going to pull out my X and my Y. Right? In order to do this math, I need them there doubles. Okay. Now, this rotation that's coming in, it's in degrees. It's needed to be in degrees inside of the JavaFx methods. But in order to do this calculation, I'm going to convert it to radians. And this may actually be something you know. Let me get this in chat. How do I convert degrees? Right? Rotation is in degrees. I need to convert it to radians. XPi. 2 times pi divided by 3. Pi divided by 80. I'm going to show you what I got. Math.pi divided by 180.0, we don't want the truncation, times our rotation. I don't know. We didn't have math whenever I was going to school. We didn't get math until after I graduated. All right. So there's my conversion to radians. I'm going to update my x value. Right? We pulled out an x from the origin. We're going to basically translate it using some type of equation. And our equation here is we take our length and multiply it by the cosine of our radians. Very similar for y. We're going to take our length and multiply it by the sine of our radians. From that, I have effectively a new x and y, and what it is my endpoint. So I'm going to return, and right here, I'm just making the object at the point of return. All right, I'm going to take that x and y, throw it back into a point 2D object. And that is going to be x comma y. At some point, it's going to make a little bit of sense as to why I'm using a point 2D. Actually, here makes a lot of sense, right? I effectively need to return an x and a y. I want this method to spit back out the endpoint, which is an x and a y. But I can only return one thing, right? I can't return two doubles. I could return like a double array. Here, I'll take the x and y, I wrap it up into one object so we can return one thing. That's kind of nice. Who's with me? So does Java not have trig functions using degrees? Maybe. We'd have to check the API. Check out the math API. Apparently there's a math to radians degrees. Interesting. So I could just basically convert it here and save it in, or save it here. Why don't we put that as like a comment or something? Math.toRadians. We're going to pretend this is paired programming and a learning opportunity. So this is our endpoint function. It should basically take the information that we provided. Right? This is the hard part. This is the, ooh, it's super mathy. We have a point of origin, we have a rotation, we have a length, and based on those things, I need to figure out the endpoint for my line, because ultimately the way we make a line is a start point and an end point, and it just draws it from there. So I'm back in my branch method. I'm ready to make this line. Initially, the line is going to be my tree trunk. Okay, so before I actually make the line right here, I've already got my origin. I need to get the endpoint. Why don't we maybe create a point 2D, call it endpoint. I don't know if I actually need this. What did I do over here? Yeah, this is what I did. And we pass in this information. We pass in our origin, our rotation, our length, and from that, this method, right, this is the method we just wrote. I'm just passing along the information. It'll figure out our endpoint for us. Return it. I'm saving it here locally into a point 2D object. Now when we go to make our line, I'm going to pull out the x from our endpoint. This is also going to make sense in just a moment as to why I've created that variable. And I'm going to pull out the y. And we're going to test that. Okay, I'm going to run this bad boy. We're making, this should help us with our tree trunk. It should change the actual endpoint, right? That was what this whole thing was trying to calculate. We're basically starting at the kind of bottom center. We should be drawing one like straight up. This rotation may ruin us, but it should be 100 pixels long. Where is it? It's very sneaky, but it's actually right there. Right? With zero rotation, we're just drawing a horizontal line. Help me rotate it. I want it to go straight up. Switch X and Y? No, we just need to rotate it. We just need to rotate it. Let's try that 90-degree rotation. Okay. I'm going to run it again. What had happened? I see kind of a little dot. What if we did negative 90? Oh, I'm not actually rotating it. There we go. Oh, sorry, that does work. Boom. So that's all interesting. Maybe dealing with, because the X and the Y, right? The X and the Y are both going down positive. Maybe that's it. Okay, next thing I want to do is we're doing our point in terms of our width and our height, right? So the idea is if we scale the size of the window, that our tree trunk will still be in the bottom center. We need to also scale the length based on our width or our height. So looking at this currently, if I was to trend with this, what this number is like 1/4 of either of these. So instead of just putting a flat 100, what I would highly recommend here is based on our height divided by 4. What this means, again, is if we do end up scaling our window size, the position of our trunk is going to change as well. But I also want the height to adjust, like how tall it is. Why don't we play with that real fast, right? If I upscale this to 800, our tree trunk should basically adjust where it's at. But also the size of it should adjust. Pretty cool. That's why I kind of recommend the use of the variables. It's the whole reason that our width and height is way up here. Sweet. So that gives us our line. Right? We have our starting tree trunk. Let's pull up a fractal tree and kind of show our next steps. A fractal tree. Right, this one is probably closer to, where did he go? Show it to me. This guy is kind of close to what we're going to be doing, but I want you to know, like, we're classifying a section as a branch. A branch is one line with 2 lines that come off of it, right? We see that one rotates this way and one rotates this way. That is then a branch that has 2 lines coming off of it. This is the recursive nature of this. We're basically defining something as a branch, which is a line with 2 lines off of it, but each of those is also a line with 2 lines coming off of it. And we just keep doing this. At some point, we'll stop, and that's kind of arbitrary. We'll see that. Our base case is a little arbitrary. So I'm down in branch. We haven't completely defined what a branch is. We're just drawing one line and adding it to our scene here. I need to then do this effectively again. We're going to have a recursive call to branch. And I ask you, right, this is what we've drawn so far. I need a new line to start here. Right? I need to draw one of these 2 lines. My question is, what is the point of origin for either of these 2 lines? The endpoint, right? This is part of the reason that we went ahead and saved this into an object, right? I saved this here locally for a reason, because the new branches, their origins are the endpoint of the line that we just drew. So I'm going to start a branch at endpoint. Okay, I need to rotate it. Rotate it how much? Well, if we think about it, why don't we, I think we're thinking like 45 degrees. Let's try 45 and see where that gets us. And we'll end up like playing with that maybe. Okay. And then lastly, I need it to get smaller. So we have this length coming in. Initially, that length is based on my current width and height, about 100. I want it to be maybe about 2/3 the size. And so we're going to pass in length times 0.67. I'm hoping some people are upset about this rotation in chat. Let's see. We'll get their math.random. I won't do that. I want to try this. Right? We have branch, and it's calling branch, and it should make a new branch starting at the endpoint, but it's going to rotate it, and it's going to be slightly shorter. There's some bells and whistles and some alarms that should be going off. I'm going to tell this to run. And, oh, yikes. What happened here? There's no base case. Okay. What should our base case be based on? Like, what is actually changing? What is getting larger or smaller? Our length. Definitely. Our base case should be based on our length. And it's kind of up to you. Now, keep in mind, length is measured in pixels. And so you got to kind of just think, well, what is a reasonable amount of pixels to kind of stop at? If length is, let's say, greater than 4. This is what I mean, it's kind of arbitrary, right? I'm going to go ahead and put the braces there. If our length is greater than 4, then we'll continue. Now, length should be getting smaller and smaller with each recursive call. So this gives us a base case. Let's try it. All right, here's my tree trunk. We did draw a line starting at this endpoint. It looks like it's a little brutal because we're doing, what, 45 degrees? This looks like it's just like way too long, right? Shouldn't it be getting smaller? What's actually happening is we're drawing several lines just back to back to back to back, all at a 45-degree rotation. So let's try negative 45. I do see that as a suggestion. We'll then end up with something like this, which again looks like it's way too long, right? This line should be getting smaller and smaller and smaller. Good. Our rotation should update based off the previous rotation, right? Initially, for us to get the tree trunk, we did negative 90. I need this to be negative 45 in relation to this negative 90. So it's not simply a negative 45. It's 45 from what we just did. So rotation minus 45. Let's try that. Oh, look at that little boy. Right? So we came up, we did a negative 90. That got us here. We did negative 90 to then go this, I'm sorry, negative 45 to go this way. Negative 45, negative 45, negative. This keeps going until we get something that is, right at like 4 pixels or something like that. 45 is super steep. It doesn't, you can play with these numbers, and this is something that I kind of invite you to play with. And, whenever it's all said and done, this here's a negative 30, and that looks pretty good. So, yeah, it's not exactly a tree, is it? Right? Because we said that one branch should have 2 branches. Right now, I have only 1. Each branch is spawning 1 additional branch. What I want is for each branch to spawn 2 additional branches. Help me out here. We're going to call branch twice. The point of origin is the same for both of these new branches. But I want one to rotate one way and one to rotate the other way. It's as simple as taking our rotation and adding 30. Right? Here I did a minus 30. Here I'm adding 30. And again, this rotation number is something that you can play with. But I also want it to basically get smaller at the same rate. These numbers, man, I just, like variables, math.random, that's what I'm seeing. Let's try this. Oh, that's sweet. It seems very simple, right? It does look like broccoli. Very simple. But it's all because this is recursive, and we defined kind of what it is. A branch spawns two more branches. And that will then, of course, spawn more branches. And that will, of course, spawn more branches. And it'll keep going until our length gets really, really small. What do you need to see, lowest broom? Try 70 what? 70, like, you like a plus or minus here, 70? Why don't we put this into a variable? Rotation amount. Something like that. I don't know. And that would, of course, be, it could be an integer, it could be a double. Because the pixels are in doubles, it's perfectly fine to make this a double. And your recommendation is 70. So if you got a better variable name, let me know. So I like the idea of using this variable. You could also, I mean, if this is just going to be a constant, I'd consider making it a private final variable, right? There's no reason to continuously create and destroy this all over again. Why don't we do that? I'm going to broaden the scope, which seems a little bit unnecessary, but we'll make it final, and in actuality, what that's going to do is actually optimize it so that this only exists one time, it can't change, that sort of thing. That is pretty cool, Bunglu. Thank you. Okay, this is basically it, and because we are scaling our window size based on our width and our height, and we're scaling our initial length, our tree trunk, which subsequently scales the length of all the other branches, we could just update our width and our height, and it's going to adjust the size of our tree. Sweet. Okay, I'm going to leave you off with a couple of more things you can do. So what we just did was made one tree. You could consider putting that, like isolating that into a method, the process of making one tree, and repeat that a bunch, right? This is this initial branch spawning. That's all that really matters. I'm not going to do that. I'm going to leave that up to you to have some fun. The last thing I want to show you, a way that you can have fun, is this line color, right? Whenever I make a line, I'm setting its color here. So you could, change the color of your tree, right? I'm setting every line to red. Okay, but what you can do, because we're doing this each time we make a line, is that you could change this. You could random it, for instance. So I'm going to pull in, if we're using RGB values, I believe they're integers. So why don't I create some type of integer RGB, and I'm going to random the value. What it means is that each branch is literally going to be a random color. Now, RGB values, they range from 0 to 255. In total, we have 256 possible combinations. So I'm going to random an RGB value, and then just kind of stick that in here. Now you could random 3 different RGB values, one for red, one for green, one for blue. You can make this fade over the life of the tree, but the way we end up creating a color is color.rgb, and I'm going to pass in this this integer 3 different times. It's the same RGB value. Yeah, we could do 3 different ones. We'll try that. I'll show you both ways. You're only going to get gray? Well, I get shades of gray. So why don't we pull in one for red? And you could just do this whenever you go to create the color. Red, green, and blue. And I'm going to make my color based off those values: red, green, blue. And I hear a lot of suggestions on playing with the rotation, something what, over 90? About 110. Let's play with that. Here we go. Should be random. And I end up with this monstrosity. Okay. I played with trying to fade it, right? Like what's changing over the life of the tree is the length. So randoming a color that scales with the length of the tree, you can get it to basically transition. Like as the tree goes out, it starts to change in color. And I didn't really get anything that I liked, but I'm going to invite you to attempt that on your own. Transition this color based on the length and see if you can find some type of formula that you like so that the tree kind of changes color based on that. That's going to wrap us up, guys. This has been Fractal Trees, and it's a really cool one, and it's most often using recursion. I'm going to assign your exam prep. I'm actually feeling a little bit under the weather. It's not Corona, I promise. So tomorrow, I just want you to take tomorrow to kind of work on your exam prep. Your exam prep is going to be due Monday, but we're going to chill, and I will see y'all then.